Oh, hello there, and welcome to a calculus tutorial by Physics Man Education. I'm Physics Man, and in today's tutorial we will be focusing on finding the x and y intercepts of quadratic functions. In a previous tutorial, we discovered that the general form of a quadratic function will look something like this. Y, when it's expressed as a function of x, will equal to the coefficient a times x squared plus the coefficient b times x plus the coefficient c. Now, the y-intercept is a point that is constrained to two conditions. The first condition is that the point must satisfy this particular equation. So at the point, x will give us y. But the question is, which x do we need to find for? Well, we learned when we were doing linear equations that the y-intercept is along the y-axis. Therefore, x has to equal 0. So if we take this equation and set x to equal 0, we'll find the y value of the y-intercept. And we'll do exactly that here. So y, when you evaluate it at 0, will equal to a times 0 squared plus b times 0 plus c. Of course, a times 0 squared is going to be 0, and b times 0 is going to be 0. So the y-coordinate will simply equal c, giving us the y-intercept point being, well, we found our y value by setting x equals to 0, and we found that at that condition y must equal to c. This is analogous to the linear case, where we found that the y-intercept was equal to the trailing constant at the end of the function. Now, in terms of finding the x-intercepts, this can be a little bit more complicated. And today we'll discuss a little bit about why this is more complicated than the linear case. And then in future tutorials we'll discuss some strategies on how to solve for those x-intercepts. I say that if you take our general equation and set y equal to 0, which is the condition that you must have in order to solve for x, you will get this equation. 0 is equal to a x squared plus bx plus c. And this is the equation that we have to solve in order to find the roots, or the x-intercepts. But because there is a leading square term, there will be, in general, up to two possible solutions. There may be 0 solutions, there may be 1 solution, and there may be 2 solutions. This is 3 cases. I'm going to write down the cases first, and then I'll illustrate them immediately afterwards. So case 1 is 0 solutions, which means no x-intercepts or no roots. Case 2 is 1 solution, which will mean only 1 root. And case 3 will mean 2 solutions, which will mean that there are 2 roots. The reason why you get these classes of solutions is because of the parabolic shape that will be defined by this quadratic equation. You may remember that we discussed that a little bit earlier on. So, I'm going to draw some axes here. Where this is x, and this is y. And we can imagine a few different types of parabolas that may exist on this chart. I'll start by drawing a red one that looks like this. As you can see, this red parabola never even touches the x-axis and therefore never crosses it, and it has 0 roots. So if you try to solve this equation that describes this parabola, you would find 0 solutions for x. Now imagine this green parabola that I'm going to draw next. If I draw a parabola that looks like this, you can see that here at the very vertex of the parabola, it barely touches the x-intercept, but it does not cross the x-intercept. There's only one exact point where this will be touching the x-intercept, and that means that when we solve this equation, if it describes this parabola, we'll have one solution, meaning one root. And finally, we can imagine a parabola that looks kind of like this blue one, where it crosses the x-axis, and it will cross it twice. That means that we will have, in general, two solutions with two roots, and each one of those solutions will be unique or different from each other. Well, that pretty much concludes this tutorial. As I mentioned earlier, we will go through some examples of how to specifically find these roots, and some of our solutions will be quite general. And I hope that this tutorial was useful. Again, this was produced by Physics Man Education, and I'm Physics Man. As always, I'll see you in the future.